Good morning and welcome. Today we're looking at Faraday's law of electricity. I believe this is not the first time you are hearing about this. Our objectives for today is to know the Faraday's law. So we are knowing the Faraday's law and its mathematical application, mathematical expression. Then we are understanding the first law and its application. So we know the law, next we understand the law and its application in solving equations. Then third, we know the second law, Faraday's second law, and we understand the second law and its application in solving equations. So let's dive right in. Faraday's first law of electrolysis. What does it state? Laws are constant, and so when we say something is a law, that means it binds. So you should know your laws. So it states that the mass of an element M discharged during the electrolysis of an electrolyte is directly proportional to the quantity of electricity passing through it. I'll go over again. Is that the mass of an element discharged, during electrolysis of an electrolyte is directly proportional to the quantity of electricity passing through it. So those are the three keywords. The mass of an element is directly proportional to the quantity of electricity passing through it. So what does that mean? That means the more electricity passed through an electrolyte, the higher the mass of the substance or element that will be discharged, either at the anode or the cathode. So basically this is the mathematical expression. Mass is directly proportional to quantity of electricity, Q. And what is quantity of electricity? Quantity of electricity can also be presented as what? As Q is equal to IT. So therefore we can say M is directly proportional towards I times T, where IT is equal to Q. So I is your current in amps, T is your time in seconds. So that is what you want to know, that mass is directly proportional to quantity of electricity. So anytime your quantity of electricity increases, your mass should increase. If you are expecting a higher mass of a substance, you will use a higher quantity of electricity. It is that simple. Just now, mass is directly proportional to quantity of electricity. Okay. So what does that mean when we encounter equation? So when you remove the sign of proportionality, which is this, we call it the sign of proportionality, you now and put a constant, you now have that what M is equal to EQ, or M is equal to what EIT, because I told you that Q is equal to what IT. Q is equal to IT. So from here, E is equal to what? M over Q, where E is a constant, and that constant is called what? The electrochemical equivalent. When you see something is a constant, it does not change. So whatever, if you get a mass and a quantity of electricity for a substance or an element, and you now increase the quantity of electricity, and you get another mass. What we are saying is that if you divide that mass, the first mass, which is M1, over the first quantity of electricity, Q1, you should get the same thing as your M2 divided by your what? Your Q2. So this is what guides, this understanding is what guides our solving of equations that involve Faraday's first law of electricity. So on your right hand side here, it's still the same thing we are looking at, but this time around we have changed our Q to what? IT. So That is it, as simple as that. So let's look at an example. You see, during electrolysis of a copper solution, 5 grams of copper was deposited in 10 minutes when a current of 1 amp was passed. Calculate the time required to deposit 20 grams. A, if the same current was passed. So now they are telling us that the current was still the same, but they changed the time. Then B, if the current of 2 amp was passed. So we have 2 questions. Let's dive right in. So solution. For your A, remember that we said that what M1 over Q1 is equal to what M2 over Q2. So you want to write out your data. What is your M1? Your M1 from here, M1 will be what? 5 grams. What is my Q1? Q1 will be what? Was you say 5 grams was deposited in 10 minutes when a current of 1 amp was passed. So we have our current I1 is equal to 1 amp. Then our time T1 is equal to what? 10 minutes. But remember that time is always in seconds, so you have to convert 10 minutes to seconds. So times what? Times 60, which is 600 seconds. Then we have our M2, which is what? 20 grams. Then we have our what? Our I2, because it told us that for the first question, if the same current was passed, so we already know that okay, our I2 will also be what? 1 amp. So you can solve now. So let's solve it. Basically, we put our M1, so 5 over, remember that we can change Q1 to what? I1 T1. So we have I1, which is 1 amp, times T1, which is what? 600 seconds. 600 seconds is equal to our M2, 20 all over what? I2, 1 amp, times we are looking for what? Our T2. They say what will be the time? Yeah, that is the question. Calculate the time required. So we are looking for our T2. So from here we cross multiply. We have our T2. Now 1 times T2 is T2, so we have T2 times, let me just say 5, is equal to 1 times 600 is 600, so 600 times 20, so 600 times 20. Then T2 is equal to what? 600 times 20 divided by 5. So 5 here 1, 5 here 4. So 4 times 600 is what? That will lead us with 22,400 seconds. So this is our answer. So you can convert this to minutes by dividing by 60. If divided by 60, that's about 40 minutes. So 40 minutes. That's basically that for that. Okay, let's look at the B question. So for the B part, if a current of 2 amp was passed, what will be the time required? So let's see. similar thing. We take our data first. Our M1 remains 5 gram. Our I1 1 amp. Our T1 is what, 10 minutes, which is equivalent to 600 seconds. Then our M2 is 20 gram. Now they are telling us that our I2 will be what, 2 amps. So 2 amps. Then we are looking for our what, T2 is unknown. So therefore we have what, M1 over, let me just use this, I1 T1 is equal to M2 over I2 T2. So from here, if you are looking for T2, you can make T2 the subject of formula for ease. So T2 if equals multiply, T2 will be equal to M2 I1 T1 all over M1 I2. Yes, so T2 is equal to, what is my M2? M2 is 20 times, what is my I1? I1 is 1. What is my T1? T1 is 600 all over, what is my M1? M1 is 5 times, what is my I2? I2 is now 2. So you divide 5 here, 4, 2 here, 1, 2 here, we have 2. So 2 times 600 is what, 1200 seconds, which is equivalent to, divided by 60, we have about 20 minutes. And yes, that is your answer. Those are your answer. 40 minutes for the first and 20 minutes for the second. Welcome back. So looking at Faraday's law of electrolysis, we have seen the first law and its application. What did we say the first law is? We say the mass of an element deposited is directly proportional to the quantity of electricity. So those are the 3 keywords in this law. It states that what, the mass of an element discharged is directly proportional to the quantity of electricity, and this is the mathematical expression. M is directly proportional to Q. Then we solve the equation. The equation says during electrolysis of a copper solution, 5 grams of copper was deposited in 10 minutes when a current of 1 amp was passed. Calculate the time required to deposit 20 grams. So if it took 10 minutes with 1 amp to deposit 5 grams, they say A, if the same current was passed. So if they still pass the same current, that means it will take more time because it is directly proportional. And when we solved for the first question, so that it took what, 40 minutes as compared to 10 minutes for 5 grams. Then they increase the amp, so they have increased the currents, and it now took what, 1200 seconds, which is 20 minutes to deposit same 20 grams. So one thing you should know here is that the quantity of electricity in case A and B were the same. That is why they were able to deposit 20 grams. How do I know that? Remember I said Q is equal to what? IT. So what is my I here? It was 1 amp. The current did not change. And what was the time we got? 2400. So 2400 seconds. And what is now our quantity of electricity? 2400 coulombs. Are you seeing it? So the time made up for the 1 amp that was not changed. Now let's look at our B equation. They gave us what? Our current was what? 2. So 2 amps times, what was the time we got? 1200 seconds times 1200 seconds. Yes, the time was lower here, but the current was higher, and if you multiply it, you still get 2400 coulombs, and that was why they were able to discharge same mass of that same substance. Okay, so let's move on to Faraday's second law today. So Faraday's second law, what does it state? It states that when the same quantity of electricity is passed through different electrolytes, so the word here is the same quantity of electricity passed through different electrolytes, the relative number of mole of the element discharged is inversely proportional to the charges on the ions. So the mole of the elements is inversely proportional to the charges on the ions. So if you see the mathematical expression, these are the 3 parts we just took away. So mole of the element is inversely proportional to what? To the charge. So N, which is mole of the element, is inversely proportional to the charge. And if you want to introduce a constant of proportionality, what that means is that what? Our N1 C1 will be equal to our N2 C2, and this is the basis of any equation that involve Faraday's second law of electrolysis. But there is a provision here, provided that what? The quantity of electricity is the same, and that means if you multiply your current and your time, it should be constant. Okay, so that leads us to the next part. We want to also know that what? Amount in mole, just the way amount in mole means mass over molar mass, amount in mole in electrolysis can also be your quantity of electricity, which is Q. Now IT is equal to Q, so this is also Q. So your quantity of electricity all over your charge times what we call the Faraday's constant. The Faraday's constant. So where I is equal to what? Current, T is equal to time in seconds, C is charge, and F is Faraday's constant, and the constant is what? 96,500 coulombs per mole. So what that means is that for every 1 mole of a substance to be deposited, you need 96,500 coulombs of electricity. 96,500 coulombs of electricity. So if N is equal to IT over CF and N is equal to mass over molar mass, therefore we can say mass over molar mass is equal to what? IT over charge times Faraday's constant. So take note, this is another important equation. An important equation you want to also know about. Okay, so let's quickly solve our question. They say 2 electrolytic cells are connected in series. The first cell contains silver nitrate solution and the second contains copper 2. So the charge on this copper is 2, while the charge of silver here is +1. If 1.08 gram of silver is deposited, so solution, we want to write our data. Our mass of silver, this mass M of silver, H is silver, is equal to what? 1.08 gram. of silver is deposited in the first cell. What mass of copper? So now they're asking us for mass of copper. So they're asking us for mass of copper, which we don't know, that will be deposited in the second cell. In the second cell. So how do we know? Because they say what? They are connected in series, and in series connection, your current is constant. The same current that passes through the first electrolytic cell that passes through the second electrolytic cell. So from that statement that they are in series, I know that the current is what? Constant. So therefore, I will say my N1 C1, which is charge, is equal to what? N2 C2. But they did not give us our amount to move, but they give us mass. And I know that what? My N is equal to mass over molar mass. So what will I do? I will say my M1, which is mass 1 over the molar mass of the first substance, is equal to what? Times C1 is equal to mass 1 over molar mass of the mass 2 rather over molar mass of the second substance times the charge of the second substance. And let's solve now. What is my M1? My M1 is my M silver. So you can still say M silver. So it is looking more pleasant in the equation like this. So I just decided to stick with it. So my silver is 1.08 gram. 1.08 gram divided by what is the molar mass of silver? 108 gram per mole. Times what? Times the charge. What is the charge of silver? I told you that the charge of silver is what? Plus 1, which is 1, while the charge of copper is what? Plus 2, because it told us copper 2. We also have copper 1, but this one is copper 2. So times 1, which is the charge of silver, is equal to, we don't know the mass of copper, divided by the molar mass of copper, which is 63.5 times what? What is the charge of copper here? 2. So from here we can solve and divide. So this will now lead us to M2, 2 times M2. So we have 2M2 is equal to, if you cross multiply, is equal to 63.5 times 1.08 divided by what? 108. And what would that give us? So basically that will give us 0.635. So 2M2 is equal to 0.635, and that will leave us with M2 is equal to, so basically that will leave us with 2M2 is equal to 0.635, and that will mean M2 is equal to 0.635 divided by 2, which is equal to 0.3175 grams. And yes, that is our answer. That's what we get when same quantity of electricity is passed through a solution of copper. Thank you very much. See you in our next video.